Is preferred, yes. My boss at Moody Gardens, Greg Whitaker, is our husbandry manager. He's basically in charge of all the animals on property. He has yet to graduate from A&M. He's been going to school for about 20 years now. He's missing, I think, 6 hours or something. So, yeah, it's really degree and it's also experience and longevity, because you can learn all that you want out of a book, but until you actually apply it, you don't really learn anything. That's a big thing with chemistry. I mean, chemistry, you can sit down and look at the periodic table and all the things that you look at the balance equations and all those things, until you actually see it working in front of your eyeballs and seeing how it affects the animals in the water and the tank and everything, you don't understand it. So that's a lot of fun, and so this is basically water chemistry and water quality. I said science, nature, magic, or just blind luck, and I think a lot of times it's a synergy between all four of those things. Sometimes you don't know why it happens, and you're glad it happens, or you're disappointed it happens. So, sort of go through some of the things, like I said, some of the things that we do, and talk a little bit about water. And if y'all have any questions or want to add anything, please do. I'm sure y'all's experience with reef tanks and some of the tanks that y'all have had are way more in depth than some of the things we've done, and so your input is highly appreciated. So in the course of putting this slideshow together, Bob and I sort of brainstormed on a few things, and I learned lots of new things and learned things that we weren't doing that we should have been doing. So next slide, please. As you know, this is water, and that's our major concern is water. Just some of the representations of the chemical formula of water. And next slide, please. And we live in a world of water. 3/4 of the earth is water, whether it be fresh water or salt water. And it really is in our hands. I mean, it's kind of, a mushy slide, but it really is in our hands, because it's up to us. As aquarists, we're a little more in tune with nature, and we know by our anthropomorphic detections what happens to the water out there, whether it's fresh water, salt water, or a little of both. So, next please. Water sources basically for our use is we have tap water, which we use every day, whether it's drinking, cooking, showering, washing, whatever we do. You go to the magic tap, you turn it on, and there's water. It just happens, it's just there. And you really have to stop sometimes and think of where that comes from. Does it come from the Edwards Aquifer? Does it come from Lake Houston? Does it come from the Colorado River? Where does it really come from? Now, also, of course, salt water. A lot of aquariums get their water from natural seawater. So, next slide, please. Now, in our everyday life, we treat water just as much as we treat water for aquariums. The water here in our area is very hard water, high in calcium, high in minerals. And a lot of times use softening agents, and helps sort of soften the water up. And everybody's got these on their faucets, because you don't know what's coming out of that faucet. There's all sorts of drugs and chemicals and nasty bits that you don't want to drink. So it was just a little carbon filter. There ain't much to it actually. So we treat water every day in our lives, whether we use it or whether we take care of it in an aquarium. Next slide, please. Of course, this is what we're interested in, is aquariums. Whether it be a 20,000 gallon captive reef tank. This is Joe Yaiulo's tank up in Atlantis Marineland up on Long Island. This is actually an aquarium. It's not a picture of a reef, believe it or not. Pretty damn beautiful reef, actually. Guy knows his stuff. And this is our 1 million gallon aquarium in Moody Gardens. Fish only tank. And they all require some manipulation of chemistry, some more than others. As you know, some of the challenges and trials and tribulations that you have with reef tanks, they can be give you a headache sometimes. So next slide, please. I sort of put this up there because water quality and water chemistry are really, it's a chemical equation. It should be in balance. You have one, you have the other. You don't have one, you don't have the other. I think they're both interchangeable. For us, water quality, for our way that we look at Moody Gardens is it has to be aesthetically pleasing. Our guests come to the, they don't want to pay their 20 bucks to get into the aquarium and not be able to see our fish. So the water has to be clear to them. That's clean water. You can go out to Galveston and the water can be sandy and frothy. That's clean water. It just happens to be very turbid because there's a lot of mud and sand stirred up in it. It's still clean water though, but it's not aesthetically clean or pleasing. And of course, water chemistry. Water chemistry is providing an optimal and healthy environment for our animals. Our animals live in an environment where they're intimately tied to their environment, which is their water. They have bad water, they're not going to do well, they die. And that's the bottom line. They have good water, they're going to do well. They're going to grow, they're going to prosper, they're going to reproduce, they're going to look healthy. A little bit about what we do. This is the aquarium pyramid at Moody Gardens. We have approximately about 2.5 million gallons of water located in this building, in the pyramid. And next slide. We're located off of Offit's Bayou. This is a big bayou here that's actually sort of off of West Galveston Bay. This is Houston way up here. And you can see this is the aquarium pyramid. This is our rainforest pyramid. And this is Offit's Bayou. We actually draw water in. This is the kernel. This is our paddle wheeler that goes out. We draw water in from this well, I'm nervous when from the pier all the way to the aquarium. We also discharge water into these retaining basins that eventually gets pumped back out into Offit's Bayou. Now I think that's a real, another concern is biosecurity of our water. How many of y'all vacuum water out of your tank and really don't think of where you put it? Non-native introduced animals is a real problem, not so much here, but look in Florida. I think last raw meeting, there was a girl there from the Florida Department of Natural Resources, and she said right now to date they've counted over 30 established marine fishes off the coast of Florida that are non-native to Florida. So you really have to concern, it's not just fish, it's invertebrates, diseases. I mean, you really never think of a disease that may come in on a Pacific fish, and you're treating it or you're doing something with it, and you put that water out, and let's say you just drain it out into the street and goes in the storm drain. The storm drain goes into the bayou, which empties into the bay. All of a sudden, we have a disease that we can't control because there's no natural control for it here. So that's something to always think about. Here's Offit's Bayou. Again, this is an offshoot of the bay. It's very salty this summer. The salinity actually got up to 38 parts per thousand, believe it or not. Ocean water is 35. So it's basically just a big bowl unless there's a lot of rain or we have a good hurricane that washes it out. It's just a big bowl that evaporates. And it went from that last winter, it was 24 parts. Yeah, 24 parts up to 38 within about 6 months. So really helps us out because we don't have to buy salt. So this is our intake. Boring, but this is our intake building. We have a big pump in there that we can actually pump water out underneath the thing here, and it goes out to the building. And we treat our water. We bring our salt water in. We have a large building that's about 3 stories tall that has a series of tanks in it. And our life support staff can actually take the water, add chlorine to it to break point chlorinate it, which means they take it up to about 10 parts per million for at least 24 hours. Then they dechlorinate it, they can run it through filters, and then that allows us to use it in the building, whether it's fish, mammals, birds, or whatever. We also treat fresh water. We use just tap water, and then they add, what do you add? Yeah, same thing as amicable. So, and then we use that as well out in the quarantine building. We do treat some of our systems with RO units. Y'all are all familiar with RODI units. We treat that. We use virgin water or the raw seawater that we have coming in and out of offats. We use that mainly for most of all our aquariums, even our reef tanks. A little farther in the presentation, we'll see the chemistries that we get from offats, and they're not the best, but you know, you can't do better than Mother Nature, I think, and you have to do what you're given. This is also a water treatment plant on property. We got somebody wrote a really nasty letter to the Galveston Daily News this summer because, you know, we're all on a drought and water conservation, et cetera, and they used to say they would drive through property and see us just wantonly watering our plants, water everywhere. It's like, damn, darn, how can y'all do that? Well, we have a treatment plant that we actually take from, there's a sewage plant adjoining our property. We take gray water from that plant. We can actually run it through these RO membranes, and it actually comes out too clean. You have to remix. We make about 75% RO, and we have to remix about 25% of the gray water to add some nutrients back to it. And we make, this makes about like 50 gallons on a good day. This makes 1 million gallons a day. Like, holy cow. When you want to have an RO unit that makes that much water. But, and even then, especially in the summer, it can't keep up because not only do we water our property, Moody Gardens, we also water our golf course. Not our golf course, but the golf course that we manage. So that's all gray water that's been treated. So it's good recycled water. Next slide, please. Exhibits and animals that we take water for. This is our South Pacific exhibit, 100,000 gallons. This is our kelp exhibit, North Pacific. It's about 16,000 gallons, cold water tank. Next, please. We have some local tanks, a little beach tank, an oyster tank. We have seahorses. We have, you can probably see back here, we grow unicellular algae as food. Corals, this is Acropora palmata that we're growing up from our program that we've been involved with Sea Corps down in Curacao. And this is really cool. Anybody know maybe what that coral is? Let's give it a guess. That's a Strangia astrophoremes. That's a coral that we actually chipped off of the dock where I showed you where we get our water from, out of Office Bayou. Believe it or not. That's real. It's called star coral, and it's a non-photosynthetic coral. And a couple of staff went out there and they chipped it off, and we brought it back, and it's been doing great. So, you know, so you can tell people that there's actually corals found in Galveston Bay. Yeah, pretty neat. Next, please. But that sort of shows a good contrast between the two, because you got, of course, the corals that we're used to that need good, clean, crystal clear water with lots of light, trace elements, yada yada. And then you got those poor Strangia that are living out in Office Bayou. You can't see this far in front of your mask, and they have no light whatsoever, and they got skanky water, but they do great. So, also our quarantine building where Bob lives. That's where we quarantine all our fish. And all the way up to our fish only 1 million gallon tank. That's our Caribbean exhibit. It's 90 feet across, 20 feet deep. That's where we have all our big sharks, our sandpipers, and our browns and everything. Next, please. Chemistry is also very important because in our quarantine building we treat our fish, and we generally use osmotic doses. We either treat them with hyposalinity or hypersalinity. This particular fish came from our Caribbean tank, and we have them in hyposalinity. Went from 30 down to 15. Basically, it's got monogenean trematodes on it, monogenean trematodes, and that's probably the best. You know, quite honestly, there's not much you really can't treat if you use hyper or hyposalinity. You know, so it's a good way to treat animals. But it's really important. I mean, chemistries on this is important because if we happen to let the salinity get up to 20, we're negating the treatment. So, and of course, another important aspect of water quality for Moody Gardens is our touch tank. We have, God, I think yesterday we probably had 600 school kids come through. And each one of them have their grimy little hands stuck in that tank at one time or another. And they're all, you know, and picking their, yeah. So you can imagine the stank that's floating around in that. And one thing we really have to be careful of is fecal coliforms. That's a real issue with public aquariums like this. And there's no rules or regs. For the most part, aquariums sort of police it on their own. We also need water for food. We go out and we catch our own mice and shrimp out in the bay, which are very fortunate. Saves us about $100,000 a year to catch our own mice and shrimp. And we have rotifer cultures that we use some of the green water to feed. Of course, rotifers feed everybody. Yes, sir?
Do you treat the mice and shrimps that you bring out of the bay?
No, sir. The only we gut load them before we feed them out. We generally stick them in some DI water, okay. And we'll put Selco or some sort of vitamin supplement or something. You know, gut load, and then we'll feed them out. Yeah. That's always, you sort of tread a fine line when you're talking live food, because, you know, on one hand it's great for the animals because you can't get much better than live. On the other hand, you don't know what sort of things you're introducing. And so sometimes it's just best just to go like this. Hope for the best.
I guess when you treat those, are you going straight from salt water to fresh water as part of that? Before, you know, after you load them, before you actually introduce them into the tanks?
Yes, we treat them. That tank is virgin line, so it's probably the virgin line's running 34, and they're going from 34 straight into 0 when we got
that
loaded.
doesn't kill them? I mean, that's
I wouldn't leave them there for a long time, but it doesn't kill them.
Okay.
Yeah. And the other things we have in there, is, you know, mammals and birds. Yeah. Yeah, unfortunately, people love those little black and white things. We want to, never mind. But one of the things they're talking about, the mammals, is it's a requirement by the USDA that we're required to turn in weekly coliform samples. And that's another part of our water chemistry or water sampling that our vet tech does. She takes samples out, and they have to hit a certain level. If they go over that level, we have to retake a sample and average it out. And of course, these are cold water, especially these guys, very cold water. And chemistries are just important on these. Not so much, but a little bit on these guys. They mess up their eyes if their chems aren't right. And, you know. Next, please. Biggest thing about maintaining good water quality and good chemistry is your life support systems, whether it be simplistic or whether it be really complicated. It doesn't matter on a 1,000,000-gallon tanks or a 10-gallon tank. Basically, you got to have the same types, basic types of filtration. You got to have biological, you got to have mechanical, and for a lot of people, you got to have chemical. If you don't have that, you ain't gonna be able to keep anything alive. So just sort of go through. Next, please. You got to remove the water somehow, and usually you do that with a pump. You can do it with air, but we do it with pumps. These are 50 horsepower pumps right here that we use on our Caribbean exhibit. We have 7 of them, and they push about 1,200 gallons a minute. So that's right at, how much is that, 8,400? 8,400 gallons a minute. We can turn the water over in about 3 hours in 1,000,000 gallons. So, but whether it's a 50 horsepower pump or this little quiet one, 3,000 right here that we have out in quarantine, it's all the same thing. It does, this pushes water and that pushes water. It does the same thing. Size really doesn't matter. Next, please. Biological filter. Again, I'm just sort of drawing some comparisons. This is on our Caribbean exhibit. It's so big it has to be outside. And the bio balls in this thing are about the size of a football, just about. So, and then some unique out in quarantine, we have these old aquariums that we've done, and this tank right here, basically the only biological other than maybe the sand filters, are these little trickle filters right here. And they do a bang-up job. We got sharks in that tank right now, so. And I tell you, there's nothing that PP's more than a shark. Bio balls, again, we always have bio balls floating in the tank, so they're pre-inoculated. So anytime we set up a new system, we can take these bio balls. They won't instantly digest ammonia, but once you put them in, they can start into the nitrogen cycle and pretty much finish up within about a week. So it really speeds up the process. And of course, good old live rock. I mean, you can't beat live rock for biological filtration. I mean, y'all know that. It's just the best there is. So, next please. And mechanical filters, we have big old sand filters. And a couple sand filter, we use bag filters on some of the tanks. And we also use cartridge filters. Really depends on the application and what you're doing. You have to look at your system, see what you want from that system, and then pretty much you design the filtration to make it work. Staff don't like these, but the bag filters work really good. Next please. You know, you don't want sand filters in reef tanks because basically they're big nitrogen sumps. So, but we have tanks, again, filters. These are sponge filters, and this is pretty much a dump and fill system. And then mechanical filtration and some dirty filter floss. And chemical filtration. These are carbon contact chambers that we have for the big systems in the aquarium. These things are about 15 feet tall. Yeah. So they can treat a whole buttload of water coming through. And this is our ozone unit that feeds the aquarium. And ozone is magic. It's either really good for you or really bad. Man, that tank looks great. Or you come in and go, damn, all my fish are dead. So, that has to be worked with kid gloves because they just, it's either that or having 10 billion UV lights. And of course, protein skimmers or foam fractionation. Again, these are the skimmers that we have on our, next to the bio filter on our Caribbean exhibit. Those are about 20 feet tall. And then your little skimmer that you have on the side of the tank. All works the same thing, one's just bigger than the other. Same properties though. These are the guys that make it work. They never get enough credit, but these are the guys that actually make the building work, whether it's main aquarium, whether it's a rainforest, whether it's quarantine. Same here, breaking down a pump. And this is their main control room. They're really fortunate because all the big tanks are computerized, so they can sit down at a control panel and actually type in when they open a valve, start a pump, whatever they want to do. But you still have to get out and look at what's going on. In maintenance, we vacuum our 1 million gallon tank. That vacuum tube's about this tall. And you can see our divers in there vacuuming. Same difference as you do with your little tube in your small tank, same thing. We try to get in there once a month. We try to do the entire aquarium once a month. We do Caribbean, we also do our South Pack exhibit.
You just vacuum just the surface, or you actually go down to the same bed?
We try to push this, our sand bed's about 3 foot deep, so we try to push that as far as we can.
Okay. We're worried about putting there. The reason why I asked was I always heard it wasn't really good to disturb the sand bed too much.
Yeah.
If you guys do it, I'm gonna do it.
Yeah. Well, for us, it's fish only, it's gravel, and we have a lot of fish that there's poop everywhere, and we have to get it out of the system. And it settles down, there's dead places around the decorations, around the windows and the gravel, so we have to get in there and take it out. So,
Probably a lot easier to deal with a bigger water volume doing that too than a small tank.
yeah, much easier. I mean,
Picking up a small tank can
Yeah.
You can do your parameters right.
Yeah, it's sort of a two-pronged thing. Same reasons, you know, you're cleaning the tank, but you're also doing a water change at the same time. You know, we just finished doing a 50% water change in here, so we just changed out 500,000 gallons of water in the last 2 months. So,
Sharks don't bother you when you're doing that?
they get a little curious sometimes, but they really don't bother you that much. All right, our favorite subject. Water chemistry, or how I learned to love the bomb. Elements. We'll touch a little bit on our water chemistries next, please. Of course, the goodies. That's what it all boils down to, really. And for all of us that slept through chemistry classes in school, may look familiar. But Bob still uses this, and he knows how to use it, and I'm glad.
He does.
Because I'm like, what?
When I went to school, Roy, there was only 4 squares on this.
But usually when people see this, if you haven't gone through any type of science program, or even if you have, I mean, I can look back and, you know, my non-organic, organic chemistry, I can open my notes back and have no idea. Most people go, what? And that's usually the reaction of most of my staff when I ask them to sit down, and fortunately Bob knows stoichiometry really well, and that's usually figuring out equations, and so that's the reaction I get from most of the staff. For salt water, this is just a general salt water composition, and you know, I think where I read you can find every single element in the periodic table in salt water. So to really break it down, you know, you're looking at nano parts of certain things, but this is mostly the major components of salt water, and those are the things that we deal with day in and day out. Like I said, we pump water directly in from off its bayou, allows us to use it. We're very lucky. You know, you look at some of the aquariums that are inland, and their entire water source is synthetic water. And that's a huge, you know, for most aquariums, it's probably 3/4 of their budget. It's just salt. So we're very lucky that we have this natural seawater. Of course, we do make some of our own water as well. If our water is coming in too, salinity is too low, we have to sort of bump it up with the salt that we get. And also for our RODI water. Analyzing our water chemistry, materials, and methods. The good old days, you'd go, oh yeah, tank's running good. Next please. Smells good. Next one. Tastes good. Must be good. And generally, no, go back please. Generally, you know, pretty much that's the way it was, you know. I mean, you looked at your tank, and really what Dave's doing there is you still have to do that, I think. It's called the wet thumb. You'll probably have heard that saying before, but I think you have to know your tanks. You got to be able to smell them and even taste them and hear them and see how they're running, because that's knowing what's going on with your tank. Chemistries can give you numbers, but how you apply those numbers to your animals and to your tank and the overall scheme is what's important. Next, please. Of course, you know, we've made it into the 21st century, and we have all sorts of meters. Bob brought most of the ones that we use in our lab. We have, this is a DO meter. We're able to take dissolved oxygens. This is a spectrophotometer. This is the magic machine that we can test ammonias, nitrites, nitrates. What else to test on that?
Copper, phosphates.
See? Yeah.
What's the difference on one of those compared to like the test kits that we use for accuracies and range and stuff like that?
Well, it's going to be more accurate. I think the chemistry was the same.
Yeah. Same reagents. Same reagents for the most part.
Just that your
comparing it to the side of the box, or the side of the box. We're using optical spectrometer, we'll read something like that, like 3 episodes.
So
Can't do
it
that on
would
the
be
side of the box.
100 times more precise, or 1,000 times, or 10 times more? I mean, they're obviously quite a bit more money for them.
Yeah, 100 times.
I would say that's definitely also based on how good your vision is. If your
Yeah,
vision
exactly.
is a spectrometer, then yeah. But yeah, that spectrometer, it passes the light through the solution and then it does the comparison.
Well, and that's essentially what these new Hannah checkers do too, though, as well with the dials and stuff. That's kind of why I was wondering. The hobby meters are getting close to what's
Well, it may
there
be,
more
but I'm
money.
really not familiar with what you're talking about. I'm thinking about this kit that's got colors on the side of the box.
Okay.
That's not what you're talking about.
The hand
Well,
checkers are new.
yeah, it's just it's a new device, but it's kind of that's why I want to see the differences.
Well, if you have one with you, we can do.
Yeah, we can run a test. I think we brought some ammonia reagents.
Yeah.
Who sells those?
Everybody can talk.
I'll touch on this real quick. The club has talked about for a little while now about investing in one of these, so I'm part of want to pay attention to this and see if we want to do it, but it'll be something for we bring to every club meeting, tell people to bring water, we'll set some rules, because there are some guidelines on how to gather your water and bring it, because by the time you get it from your house to where you're going to test it, the water changes, unless you gather it correctly. But we have looked at getting one for the Reef Club, and we'll talk about that in future meetings, possibly doing that next year once we're in a regular meeting routine where we can bring it. Everybody brings their water to every meeting, we can test people's water. They're definitely way too expensive to pass around, but definitely looking at it as a club thing, so.
Yeah.
Yeah, I'll go see if they've got a hand meter we can borrow to check. Fair again, so those radar handle units.
But this, I mean, that meter, it's about a $5,000 meter. So we keep it under lock and key for the most part. And Bob has will give his life if anybody tries to take it. But it gives you numbers, like Bob said. I mean, you can get to 3 places on it. And that's one of the things you have to be careful not to get caught up in numbers. But, you know, we take temperatures, we take salinity with a refractometer rather than a hydrometer, because again, refractometers can get you, and that's the value that we use in our field. And I don't know what and pHs. Next one, please. The chemistry parameters, what, why, where, and when, tell you a little bit about what we do, and get into some really good some chemicals and some crunching numbers. Next. Before we do, intermission. Go arrows. Next. This is what we do with our sharks in our spare time. We shark juggle. It's not pretty, but yeah. Beautiful P-51 Mustang that's housed right behind Moody Gardens, the Galveston Gal. And if y'all ever want to come down, they got a beautiful set of airplanes down there. I thought that was so cool. This is in Galveston Bay. This is Seawolf Park, and that's a big water spout. Isn't that neat? Next. And that's a happy puppy dog. Next. That's a happy shark. Next. And hopefully they'll be happy Texans this Sunday. That's what I tell my staff, just work. Okay, back to work. Water chemistry, dope. Okay. Analysis capabilities, what Bob analyzes down in quarantine. Daily, we in all our aquariums we do temperature, salinity, and pH. I mean that's a basic. You have to do that on a daily basis. A couple reasons. These can sneak up and really bite you if you don't take these on a daily basis. Provides a good trending base that you can go back and look to see if you're having problems, and also for continuity because you know we have a staff of 11 folks, believe it or not, that take care of all the aquariums in the building and also in quarantine. and also volunteers that take chemistry. So just to keep that consistent within the department and we get that data good, we take all of these every day, you know. And again, that's teaching the staff their aquariums, makes them go up, makes them look in the tank and actually see what's going on and what the temp is and the pH and everything. So it gives them a good idea of what's going on. Weekly, we run ammonias, nitrites, nitrates, the nitrogen cycle, calcium and alkalinity on tanks that require it, reef tanks, some of our invertebrate tanks, and then phosphates, especially in our coral tanks. And as needed, we do chlorine for our municipal water. Also, when we breakpoint chlorinate, the LSS guys will come out and they'll do chlorine, ask us to do chlorine. Magnesium, it's one of the tests that we found out we should be doing more often, because we really don't do it often. Copper and zinc, a lot of those are heavy metals that we test for, especially copper in our invertebrate systems, because sometimes when we put a system together, you don't know if the pump that we're using has a copper ring in the impeller body or something like that. And you know, we may have mysterious deaths of some of our cephalopods. You start looking at what the heck's going on, and one of the culprits could be culprits is copper a lot of times.
What level do y'all keep y'all stacked in the reefs?
Bob?
Well, it's going to be 1,200, 1,300 water range.
Yep.
I'm not sure I know what it is.
That's where I keep mine too. I'm just
Yeah.
what y'all keep y'all
That's the
stacked.
recommended value, and
I actually did that for a lady that came to work at Moody Gardens, just a number of months ago, because she was new and didn't know that people weren't doing it. So she asked me to do it for her tanks, and it came out, you know, when people up there in her part range, just like it's supposed to. Because we're bringing quality virgin water in out of the bay, not making our own salt.
that's the blind luck part of it. And
Well,
we can,
it'll go constant for a long time, and then it can just change quickly too. You know?
yeah.
So
Yeah.
we got one.
And then dissolved oxygen. You know, we can we take it on our DO meter, and take dissolved oxygen anytime we need to. And that's important on a 1 million gallon tank, because you can lose oxygen. It can go from ambient 6.5 part per million down to 2 in 30 minutes if you're not careful. So you know, when you got $100,000 worth of sharks in there, you got to be really careful. This is a testament to Bob's work. He tests over 103 systems a week. And you figure your one tank at home, it gets to be a pain in the ass sometimes. He does 103 of them. He does 70 saltwater tanks and 33 freshwater. And those are just the scheduled ones. So that doesn't count the ones that we have that we ask him to run as a special need basis. So he keeps really busy during the week. Really, why do you analyze your water chemistry? And a couple of these I just sort of took off the top of my head. You need to establish and maintain water quality parameters within the healthy and no recommended ranges. And generally, that's put down somewhere in the literature. That's usually, those have been derived by years and years of experience and experimentation. And those numbers are down there, and they're good to follow. You create a history and trending of data for your systems. Something you can go back. So if you get an anomaly or an odd number off of one of your tests, you can go back and say, "Oh, that's not right. You know, what have I done different? You know, perhaps the protein skimmer went down for 2 weeks, or perhaps you know, you're adding you know, some buffer, and like, oh damn, I put too much in. You know, you have to. So you can go back and you can look at where your tank has been and where it's going. And also have the ability to diagnose and alter any of these changes before they reach critical levels. You know, y'all have all probably been there. I don't think there's a single Aquarius on this earth that, you know, has not encountered some problem with their tank because of chemistries that you weren't aware of. And if you do take chemistries, you can see the process changing over time, and then you can be able to, you know, do what you have to do, water change, bigger skimmer, add more chemicals, whatever the requirement is. And that's what those numbers are mainly for. They're good diagnostics. Next, please. We do our chemistries out the quarantine, the animal holding facility, and that's it right there. That's where we house all our, we have freshwater and saltwater tanks as well as our lab. Next, please. You see Bob there diligently at work doing calciums, I think, or alkalinities. Sample of the samples. I think those are the freshwater samples. Yep. And we do pHs. Next, please. That's one happy camper, isn't it? Chemistry is his life. And using the spectrophotometer here. Next, please. And recording data. I mean, that is probably staff spends 25% of their day doing nothing but sitting down and writing and recording data. It doesn't help you if you take those tests and you don't put it anywhere. You've got to have that data in front of you. This is for quarantine. You can see all the temps, the salinities, and the pHs, and then the ammonias, nitrates, and nitrates that are done. And then everything is entered into a central computer database for us. And you can go back and look at the Excel spreadsheets and see, you know, where you've been and the whole 9 yards. Numbers. Remember, these numeric values are generated by water analysis are only important if they're understood through historic trends and context. Next. Which really means you got to know what tanks are for what chemistries. Is it a fish-only tank? Is it a coral tank? Is it a combination? Is it fresh or salt water? Is it a new tank or an old tank? You know, new tank syndrome. Is it a quarantine tank or a display tank? You know, chemistries for quarantine systems are way different than for display systems. Is it an established tank with established animals that you've had in there for a couple of years? Did you just add 20 new fish into a tank? You know, all sorts of things go into why chemistry should be important for that particular system. Next, please. Always remember, your aquariums are dynamic living systems. They're always changing. I mean, they're changing when you're looking at them because there's all sorts of processes going in there, chemical and biological. Like I said before, animals we care for are intimately tied to the health of their environment. Basically, you got good water quality, you got healthy animals. These are healthy numbers for a marine aquarium. Y'all are probably all familiar with these. This came out of this book right here. Excuse me. This is a great book. I don't know, any of y'all have seen this book? Yeah, it's called Marine Chemistry, and it's simple enough that I can even understand it. And I tell you, just takes it to the point, tells you exactly what you need to know and why and how to alter it or change it if need be. And these numbers came out of this book, Brightwell's book. And if y'all don't have this, you're really, really serious about the hobby, I would highly recommend it. Great book. Great, great book. But these numbers, oh wait a minute, I shouldn't be pitching that, should I? No. But it's good stuff. And but these numbers, y'all probably all know this. For marine aquariums, you know, and again, that's really sort of reef-centric, sort of for reef tanks. But that also can apply for fish-only tanks, invertebrate tanks, whatever tanks. I mean, these are just good all-around basic chemistries that everybody should be familiar with, you know. And again, it really depends on your tank, you know. If I have a North Pacific invertebrate tank, I'm not going to keep it at 72. It needs to be at 55. But that, you know, it all depends on what specific, you know, system that you're looking at. know your numbers. These recommendations are established guidelines. Like I said, years of experience and experimentation went into gating those numbers, and they're not, some guy just didn't pull them out of his butt. They're really important numbers to know. And know your aquarium and its animals, and customize your chemistries to best fit their needs. You look at the animals, and it's a lot like feeding. If you have fish this big, you're not going to feed them a fillet that big because they can't eat it. Same thing with chemistries. You don't try to do chemistries that your tank really don't need. Virgin salt water, like I was talking about, offsets Bayou. And this is the chemistries of our virgin water coming in. It's whatever the ambient temperature is. Today it's probably down in the upper 60s maybe. Salinity's 34 right now. pH is nice, 8.15, yeah. No ammonia, nitrates or nitrates, really good. Calcium, yeah, you'd sort of expect that because we don't have a whole lot of calcium carbonate out in the bays. Phosphates a little bit because there are a lot of anthropogenic influences there. And alkalinity is fairly decent. But that's total. I think carbonate alkalinity is 1.5. Right? Phosphates, that's sort of, I know all the reef people, all your reef folks are going, But we still use it in our reef tanks and it works great. We do have some problems with algae, but I tell you, it's sort of a trade-off. You have, and there's really intangibles when you use real seawater because there are trace elements in that you can never get in synthetic water. And it's just good, I don't know, it's good used natural water. It's been there and done that. It's just the animals, you can really see a difference in the animals. Using fish only, corals, quarantines, and the other systems. Changing water chemistry with chemicals. It's usually, how do we change our water chemistries? There's lots of influences on that body of water inside our aquariums. Light, whether you do a water change, whether you have a fan blowing on it, evaporation, just about anything that you do to your system influences the chemistry in that system. Whether you feed or not, what kind of food you're feeding, etc., etc. And generally, a lot of times that system will come back into balance on its own for the most part. But when it doesn't, we have to augment the existing chemistry with chemicals. And that's, again, we use a lot of marine chemicals because it's easy for us. And I don't have to explain to the staff really how to use it much. It's just, okay. And they pour it in. And, or sodium, it's a 50-pound bag of sodium bicarbonate. And, we may dump 3 of those into the 1 million gallon tank to raise pH. So, remember, chemicals are your friend. Use them to maintain current chemistry, you alter chemistry with it, you customize chemistry. We all customize our chemistries for our tanks. You supplement it, and you use it to feed the chemical and the biological machine that is your aquarium. And know your chemicals. Because you can buy them at the pet shop and they come in little plastic bottles don't mean that they can't be dangerous to you and your animals. You have to know how to use them. What are they? Calcium hydroxide. You got to know what sort of chemicals you're using. Why you use them. What parameter are you trying to change? What's your expected result? Do you know if you put that chemical into your tank, do you know what's going to happen to it? Raise the pH, raise the alkalinity, lower the alkalinity. What's going to be the end result? What to do if you improperly dose it. We've all probably been there where we've put too much of something in. What are the signs of under or overdosing? Do you really need that chemical? Well, you need to add it because, well, why? Do I really need it? And it's some super mongo chemical everybody says you need. And do you understand the safe use and handling of that chemical? That's another important thing. Because a lot of these chemicals have exothermic reactions and they get very, very hot when you mix them. So you don't want to blow up your the fish room or anything next week. Remember, safety first. This is our hood in the quarantine, and please don't lick your fingers after you add chemicals. That's one of our LSS guys. Next. And always remember, in your post-chemical additions, when you add chemicals to your tank, you have to perform water chemistries to see how they've worked. You're not going to add something to alter the pH and then not test it, because you may have a pH of 11 or something. It's like, holy cow. So you have to know, you have to be able to do your chemistry and see how your chemicals have actually worked. These are all examples of things that we've all added to our tanks, and there's probably more. These are just some of the ones I've come up with. Salt, just adding salt, it's a chemical, raises salinity. Fresh water, can lower salinity. Buffer, sodium bicarb and sodium carbonate. Iodine, magnesium, and strontium, calcium, whether it's hydroxide, chloride, or carbonate. All different types of chemicals that we add to our systems to alter the environment. Lots to remember. Remember, water chemistry is fun. Damn, it's fun. And know what chemistries are essential and critical to your systems. There are some things that are written in stone, the nitrogen cycle. If you don't understand the nitrogen cycle, ammonia to nitrite to nitrate, you're SOL, because you're not going to be able to keep fish alive or corals or anything else. You got to know that. And there are just certain things, and then and there are other things that are variable. And understand the values and use them as diagnostic tools. That's why you get those numbers. Those numbers aren't set in stone. If you don't get the wrong number, the aquarium god's not going to come down and hit you in the head or anything. They're diagnostics. And you look at that on how to make it better for your tank. And like I said, don't get too caught up in the numbers. Those are black and white, and use that wet thumb. That's what we all got into the hobby and the business for, because you like the animals and you like to work with them and look at them. See how are they? Are they healthy? Are they, crunched down on one side? Are the corals contracted? Are the polyps, pulled in? Or do they have good color? Are they blanched? Just, you have to make those observations and then correlate them to other things. Remember, knowledge is power. The more you know, the better you can care for your animals. And that's everything from reading books to getting online. There's so many places now you can find this information online. Always remember, though, that I'm old-fashioned. I like books, because what's written in there is usually the truth. Online, it can be, a little scary sometimes. And also meetings like this. You come and you talk to folks. You talk to folks that have been in it for 15, 20, 30 years. They've been there, done that. They've gone through the rough times and the good times. And they're willing to share that information with you. And that's the best way to learn. And you just got to do it. You can't sit back and read a book and then not experience it unless you actually get in and do the work. And remember, most of all, have fun. And that's the biggest part is, aquariums are fun. And, we have fun at Moody Gardens. I hope my staff has fun. I know Bob, he keeps us happy with food. And, he's been great because he teaches our staff all sorts of things that he's a chemical engineer by training. And teaches our staff all sorts of new things, and I really rely on him an awful lot. Great, knowledgeable guy, and we do have a lot of fun. We have fun with our sharks, with our fish, with our corals, collecting the whole 9 yards. I look at the staff and I can't thank them enough, because I have 11 folks that are really dedicated that keep an aquarium with 1.5 million gallons running. And sometimes we get challenged by a 50-gallon aquarium. You can imagine what it's like. And there are days like the holidays coming up now. We may have 3 people in on one day. That's everything from prepping food to cleaning tanks, diving, and everything else. So they work hard. But good folks, good dedicated folks. We brought on the table, I brought some literature. If y'all want to sort of look at maybe some of the books that we brought. A little bit of everything, all the way from standard methods, which are all of the EPA approved methods for water quality. And aquarium books, there's some field books up there, some coral books. Eric Borneman's book is up there. Of course, the water chemistry, the marine chemistry book. Bob brought some of the tools of the trade, so to speak, what we use. And so you can kind of see that up close. And same things that y'all use, just a little more expensive. And also I have Push and Moody Gardens here. I have some volunteer forms up there and also some facts about our guide program. I know y'all have talked about it before in your meetings, but if you're interested in volunteering, we'd love to have you, if you want to come volunteer. We didn't fare well, our corals didn't fare well after the hurricane. We lost our hard coral tank. We have some soft corals in the Strangian, the Palmata, and some of our coral garden things. But would love to have some of you folks come down and actually get involved with our corals to help us out a bit and lend your expertise and knowledge to us so we can learn some things. And it's a lot of fun to dive, I mean, you get to dive with sharks up close. We have 8-foot sand tigers that weigh 200 pounds. And just big old puppy dogs. They just, they're like that. They come on. So, but I appreciate it. If y'all have any questions, I hope I touched on most everything. I don't want to get too bogged down in equations, et cetera, because really that's what books are for. And if you need to know anything specific, you can look in a book or just ask somebody, why do you add if your alkalinity is low, or my calcium addition is not working, maybe there's something else or whatever, that's where experience comes in, because there's no set formula for any of that, I guarantee you.
Some months ago, a study came out showing correlation between using carbon and the grade of the carbon, possibly correlating to head and lateral line erosion. There was a little bit of a stir, online in the hobby about it. I'm curious what the reaction in public aquaria and commercial aquaria circles has been to that study. Are they waiting for further studies to come out to back it up, or has any practice changed? Or?
No, not really. A lot of it's anecdotal. I mean, for the most part, everybody tries to use clean pelletized carbon for the most part. Not real dirty carbon, because now this is only my experience. This is the experience of the folks in the field. For the most part, we don't use much carbon at all. I have carbon on a few fish-only tanks, and the carbon that we use I get from a place out in Florida called Aquatic Ecosystems, and it just comes in bulk. And we did have an experience with our mangrove tank. We treated it with some NS222, and we couldn't do a water change on it, so we ran it through carbon to get the medication out, and our wrasse within a week came down with head and lateral line erosion. But we don't use it enough to where I can really give you a good educated answer, because and that's always up on our aquatic info listserv for professional aquarists. That always comes up about every 3 to 4 months. Same question. And everybody will write in, this has been my experience, this has been my experience, this is what we've done. I haven't read the study, but that's...
So you guys aren't using lignite, you're using something more refined than that, more less fine generated?
We get the, it's been so long. A lot of what we use is it's probably coconut shell, which is probably not the right thing to use. But we get it in bulk and it's cheap, and that's generally what we use.
Other question I got, I've always been confused, like people make a big deal about when you get a new fish and you're going to introduce it to your system, drip acclimatize it, like, reach in salt water, get the temperature right, but then, drip it and really make sure you got the least amount of stress on that fish. But at the same time that people advocate doing, say, freshwater dips. And so if you guys are doing, hypo or hyper salinity, do you gradually move that fish in the tank down to that thing, or just like, oh, the fish is in this salinity, drop it in the quarantine tank that's at a hypo level? And
when we get fish in, again, these are our practices. When we get fish into the quarantine building, you have to assume that any fish coming in is parasites. I mean, that's a given. You're going to have internal, external parasites, unless they've been pre-treated. But when they come in, we acclimate them, drip acclimate them, generally for an hour to 2 hours. And then before they go up into the tank, especially come in with trematodes and some nasty things. And that generally, if you ever do that in a bucket, take the bucket, strain it, and then look at it, and you'll see all the worms in the bottom of the bucket. Now we have a fish, for instance, like that speedfish that came over, and we had to put it in the high salinity. You have to kill the animal. If you take too long to drop the salinity, a lot of those invertebrates will adapt to lower salinities. And so what happens is, you know, if you're dealing with protozoans, whether it be Urinema or Cryptocaryon, Amyloidinium, or worms, you have to be fast. Generally, if it's in a large system with a group of fish, we'll do it in 2 days. If it's a single animal like that, it'll come in and go immediately into 15. Because basically what you want to do is shock those parasites, blow them up and kill them right off the bat. And for the most part, the fish do good. Now this fish came in and it was laying on its side, and its eye was all skanked out, and the fins look horrible. The next day it ate for him. And you look at that fish now and you don't ever think it had worms. I mean, it was the difference between day and night.
How long do y'all freshwater dip a fish, or does it vary on the fish?
It really varies. I mean, that's the thing. They're stressed to begin with, and you really don't want to leave them in that long. A dip may last 30 seconds, and that's it, really. Yeah, you put them in there. Most of the time, they immediately go on their side, look at them, and then you just pick them up and put them in the tank.
Usually we're the limiting factor. We do it until we check it out.
Yeah.
Yeah, well, I've been doing it too long, I've been leaving mine maybe 5 minutes.
Well, you know, it all depends, because stenohaling fish, like your coral reef fish, they only live in 35 parts, and that's all they ever see. You get some animals in there that are euryhaling, for instance, some of the Caribbean fishes. You know, it's nothing for them to go up into the mangroves and live in 5-part water, and then they go out to the reef. So you may get some small fish in that a freshwater dip is not going to help, because they may have parasites that acclimate to 5 parts. Yeah, exactly.
Oh, I did big ones there.
Yeah, so that's something you have to, you know, and that's when, you know, we have a whole series of prophylactic treatments that we put fish through, you know, that have 2 series of, we use Droncit, it's praziquantel, right? We use praziquantel, metronidazole, and fenbendazole. So it's a panicure. And they get that internally, and plus a lot of times we give them a praziquantel bath as well.
I'm gonna like you said, when I did mine, I've seen all kinds of stuff.
Oh yeah, you'd be amazed. Yeah, yeah. Yes, sir.
So, from what I remember, you guys are real aggressive on the quarantine, like everything's quarantined.
Yes.
You do the medical and
30 days minimum. Yeah. Because it's sort of a two-way street. We do that because, again, we know they have diseases, and that sounds so nasty, doesn't it? They're diseased. They have parasites, and you know that, so you have to treat them for it. But then also, the guys that work out in quarantine, if you provide, you know, it's just like us. You provide a non-stressful, good environment where you got good water chemistry, you have a good place to live, you got food, you got shelter. Chances are, those fish are never really going to exhibit disease, other than what they came in with. But if you put them in a crowded environment, no place to hide, poor water quality, I guarantee you they're going to come down with Urinema, Cryptocaryon, all those other nasties. And the things that they came with are just going to become an infestation, and you'll lose everything. So, good, tender, loving care, really, that's all they need. You know, that's all they really need.
I'm gonna jump in here. Roy, thank you very much.
No, you're welcome.